all you need to worry about is how do we deal with it? We can put our iPads away now, we don't need those, we'll face down. How do we expand this, for example? What do we do? So we put x into both like so, is that what you're saying?
Yeah.
And that becomes?
X into X.
Plus 6x, correct?
Yeah.
What's that called? That's called, starts with D.
Distributive law.
Distributive law. Okay. And now, the distributive law, Sam, states that A times B plus C is equal to AB plus AC, correct? And we went through and we looked at what happens when we shove some numbers in there. So, what I want to look at today is if I've got a bracket A plus B times C plus D, what does that equal? Now I'm going to let you answer that later. We're going to come back to that. But let's go through some examples. So if I gave you the bracket 2 plus 3 times 4 plus, let's go 1, what would that equal? Adam says 25, who agrees? Who disagrees? Who's got a different answer? I think it is 25. So we need some pattern for how that works. Because that's all well and good when we've got numbers, but we don't always get numbers, do we? Sometimes we get X's and Y's and unknowns. So if I was to have this now, I'll leave it as 2 for now. How does that? How do we expand those? How do we expand those out? What do you reckon, Ashton?
Plus the 2 and 3.
Okay, so what you've done in your head is 2 plus 3 times 4 plus 1. Is there another way we could do it? How is that? Who thinks they can think of another way to do this? Cinda.
Could you just go like, I don't know, indices law? So in the brackets it could be 5 to the power of 2.
Oh, so you've gone 5 to the power of 2. That works. Any other methods?
Put it like a square and then
Not a bad method. Yep. Yep, so do this. So, oh, that's a good. So what you've said is let's go 2 plus 3. So Yannick's just said, let's go, well, 2 plus 3 is 5 outside of 4 plus 1, correct? And then he said, well, I can do what I did above, which is like that. That becomes 5 times 4, which is?
22.
Plus 5 times 1, which is?
5.
So equals 20 plus 5, which is 25. Very good. Could I do it any other way? I can see another way. Oh, Sam. Could we do it the way that Yannick just did it the other way, like with the other bracket?
Yeah.
So we could go 3 plus 2 times 5. We can just put that 5 anywhere, before it or after it, correct? And we expand that in. So that becomes what? 5 times 3, which is? Plus 5 times 10, which is? 5 times 2, which is?
10.
Which equals 25. Could we combine those methods, maybe? So Yannick's could, instead of us going like this, well, it's not times. Could we do this? Could we go 3 times 2 plus 3 times 1? So 3 times 4 plus 3 times 1. And then do 2 times 4 plus 2 times 1?
Yes.
Would that work?
Yes.
Well, let's have a look. So what's 3 times 4 equal?
12.
What's 3 times 1?
3.
What's 2 times 4?
8.
And what is 2 times 1?
1. Oh, sorry.
2.
Yeah.
And that equals 12 plus 8 is plus 3 plus 2. So did that work?
Yeah.
Now, some of you are saying, why is our lesson titled crab claw? Oh, that's not that pretty. No, that's not what I wanted. Yes, that is. That's what I wanted.
Oh.
Oh, it's like I got it,
Now, if you're unsure about why that's a crab claw, I can show you here. So if I look at, well, if I look at this example here, let's go back to A plus B, C plus D. If we apply a crab claw, what are we going to get? A times
C
plus
A times
plus
B times C.
plus.
B times C.
Is that the answer?
That's the answer.
Would you do the other techniques or would you have to go?
What's the other technique? This one? That works when we've got numbers. What's the problem with this one? Have no numbers, do it. So if I gave us this example here, and I'll just go below. If I gave us x plus 4 times x plus, what do you want? 3? That would give me what? So how would what should I start out with, Charlotte? What do you reckon?
X times X.
Yep, so that'd be a crab claw, so I've done this one. So x times x, which is
X is out to.
x squared plus, thank you, so plus,
Oh, X times 3.
yep, so plus 3x, which is this one here, plus,
4X.
so that's that one there, plus,
4 times 3.
yeah, and that's, Sammy just had a good point, he said, isn't it times? What's the operation going on there between those two?
Times.
It's the times, but we don't write it, that's a maths convention. Okay, and what's the last one?
4 times 3.
4 times 3, which gives us?
12.
Are we done?
Yes.
What can we do? Simplify by collecting our like terms. So we've got x squared plus 7x plus, and that's done. Waiting. 3, 2, 1. If I had x's and y's, could I do that last step? What allows me to do that last step? Yeah, I've got 2 x's in there, don't I? So I can collect those like terms right at the end. Now, in the homework questions, Ella, you had a really good question. You said, well, how do I do x plus 2 squared? And I'd say, well, what does that squared mean? What's squared mean? Times by itself. So rather than writing that, am I allowed to write x plus 2, x plus 2? And maybe, Ella, that might help you answer your question about how do we go about solving that. Well, I'd talk to my little friend Krusty Krab and go from there.